Hello everyone. I'll be talking about similarity searching in this section. So I'll be performing some similarity search using RDKit and Postgres database. To start up with, the requirements for this tutorial is you need a Postgres database installation. So it might be like version 9.1 or 9.3. You need RDKit installation in your computer and how to get Postgis cartridge installed. You need to know some knowledge of database queries like the select, insert, alter, or those kind of queries in Postgres database. And as an example database, I'll be showing you how to query the ChEMBL version 18 database. The ChEMBL is one of the largest bioactivity databases, and they are highly curated data. They contain very highly curated data. So now the current version is version 19, which is recently released by them. But I have version 18 on my 18 installed on my system. One of the problem of this is just not like you have this 4 sections. Uh, you just have this and you start working with it. The problem many people face with installation is like installation of the RDKit, and so for that there are some resources I have given. So to install the Postgres database, you just go to this download section and download any of your version, like more than 9.1 it should be good, and less than 9.3 because RDKit is not tested uh, version 9.3, but I have been working on version 9.3. The Postgres app, it works okay, so even 9.3 of the version is okay. uh, then you need to load the ChEMBL database. So current version is 19, so you can get the link is here. So they provide tar .sql file. You need to untar it and load the dump file into it, and you need the installation of the RDKit. You need to install RDKit, and you can get the installation instructions on this documents page here. And also so apart from that, you also need the Postgres cartridge installation. So this is it is RDKit ChEMInformatics toolkit to do ChEMInformatics using Python. And the Postgres cartridge connects the Postgres database with the functions you need to do in ChEMInformatics. For example, similarity searching in a database, so generate fingerprints or descriptors, generate like molecular properties, perform, for example, subgraph searching, like subgraphs of chemicals, or we call substructures. So to install the Postgres cartridge, you need to go here, and they have the way to build the cartridge. Now the thing is, if you find any problems of installing all these things together, so there's another way they have done it is they have actually made it a kind of a VM. So I'll come it on the next slide. So to install the ChEMBL version, you just need to run the Postgres database server, and then while getting inside the Postgres, you just create a database name ChEMBL 18, and then you log out of the database and just log in with the host or the port name. And the port name, you might not the port name is not much important, so it's up to you because you're running it in local. And then the username and the password, and the database name ChEMBL 18, and there's the dump file they provide, and you just dump it, and it will take some lot of time, like maybe 1, 2, 3 hours, because it's a very big database, like close to 1 gigs. So it's a big one. And after installing, so it has lots of tables. So let me show you. Let me see if I can. So once you go to the FTP site, and suppose for example ChEMBL 18, they provide the schema. So you should know the schema well, because it's a very it's not like a single table or two table database. It has lots of tables. So you can see the source information from where the experimental data came from, and this source information also connects the compounds, and the experimental data connects the target information. The target information has another subtable, has the binding information, and also has this approved drug data and some other general variables here. So, and there's a big compound table here which contains some properties, molecular properties. There is also some record number and source compound and everything, and the year and everything. So this is a very complicated table here. So you can see there's a lot of things here, but most probably we'll be working with this compound structure table to perform the similarity search on the database. So you can see here, so it contains this mol reg number. The mol file is the 2D format of a chemical 2D structure file of a compound. It also contains the standard INCHI, which is a like linear string notation of chemical compounds, and also contains the INCHI key. If you want to study about what are the different formats of chemicals used to represent in chemistry, so you need to go to the I571 .wikispaces.com, the cheminformatics course, which tells you to which helps you to understand what are the different formats of file of formats in people used to follow in chemical in understanding chemicals. Okay, so this is the schema of the ChEMBL, and so as we go back to the RDKit, so the RDKit installation, I would recommend you to use Ubuntu or Linux, mostly like Ubuntu and or Mac, and that should be good to get you started. So this it doesn't come on the IU anywhere or anything. You need to have a local installation of that. I have also installed in the RHEL system, the Red Hat system, and it works okay. The RDKit installation, even the Postgis cartridge. So you won't face much trouble with installation in Linux. There are some other packages also you need to get installed along with that. So this section, if you want to build your own chemical database, so they don't like, so there are like other various chemical databases like zinc, e-molecules and all, and so you might want to download that database to get into it, and then you need to pipe all the data to Postgres. So this is an example showing the ChEMBL database. But if you want to build it by yourself, so what you need to do, you need to dump the Postgres data, and then you might want to write a Python code to dump your chemical structures into the Postgres database using scicopg2 library of Python. Okay, so coming to the VM. So if you find any problems with installing ChEMBL and anything, so the people of ChEMBL DBI have already like provided you a VM, so you can get it installed from this link. The all installation instructions are provided here. So let me open the link for you. And also you need to have the latest the VM. You can get the latest VM here. To start with, you need to have a virtual box ready and download these files. All the instructions are given here. So after installing the VM and getting started, so you need to so they made a kind of a web app which is known as the My ChEMBL Launchpad. You just type after starting the VM and executing the Ubuntu. So you just log in with you just point your browser to this system and here, and like the browser. So for example, here I've already done it. So my VM is running here. You can see my VM, my ChEMBL VM is running here, and So this is the VM you can see. So it's running, and you don't need you can use this to access the Postgres database, but here is this web app, and where you can access the different uh, chemical, or where you can access the app actually of accessing the ChEMBL database. So they made an app using the Postgres database as the using the Postgres data ChEMBL Postgres database. So for example, if you want to access the ChEMBL, the web interface, and you want to do a structure search, you can do like two types of structure. You can do structure substructure search, like finding subgraphs of compounds inside subgraphs inside a chemical compound, then performing a similarity search. So if you want to draw the structure, you can draw. You want to upload a file of smiles, you can do it. So for example, let's draw a structure, uh, and then you just point it, say, and these are the fingerprints, which is different types of fingerprints which are available here on RDKit, and which is provided in the database. So the person already generated these fingerprints and dumped it on the database, and you need to select which one, and it will get generated for this compound, and it will perform the search. So there are two types of similarity measures they did. It's Tanimoto and Dice coefficient. Tanimoto is also known as the Checkaard coefficient. So let's start and just click this button, and it will help you to search on the database. So it's searching. Uh, there's also this tutorial is given, and also you can calculate chemical properties of the compound. For example, if you want to draw the structure again, and if you want to calculate the properties, say for example NH2, and just calculate it, and it will calculate you the results and show you the query. It converts the structure into smiles, which is a notation of chemicals, and it generates the different kinds of your different kinds of results for you. Um, yeah, and these are the results what you get here for the query, and the threshold is set to most probably 0.5, so you get results above 0.5, not less than 0.5. It's been already set inside the Postgres cartridge. Uh, Also, you can get some IPython notebooks where you can get how to use the RDKit Python and RDKit and Python together, and maybe query the database. And there is also some machine learning examples which are given here, and also how you can use the pandas, the data frame, and also like to use the machine learning framework here. There's also some introductory Python notebooks, like Python. Yeah, so, and the libraries which is used here, and what how you can work with the RDKit tool here. This is all with the Python cartridge and Python toolkit. So also it has this PG admin console. If you want to access the database, you can query using the PHP admin. Also there is the KNIME integration. This is a pipeline tool. So these are pipelining tools where you have these nodes here, then you can connect these nodes and perform the queries. So data pipelining is one of the another uh, way to efficiently process and process and visualize and predict, or you can do like all the data processing using the pipelining tools. There's another pipeline tool called the pipeline pilot. That is commercial one, and this is the KNIME, which is the free version. You can just there's some other tools also other cheminformatics tool where you can integrate in KNIME, and then you can run this uh, run this pipeline to get your results. So nowadays people are like using it quite a lot, and there are some lots of workflows here. So I will try to make some examples for KNIME to do some data processing, and which should be later on this course. It's not a must to learn a KNIME like for this course, but should be helpful for you because it's a you can not only do cheminformatics but also other data analysis like social data or climate data or something else. Uh, so this is all about my ChEMBL, and let me show you how do I access the Postgres database. So this is so I'm I'm SSHing to this ID. Uh, so ChEMBL is the username, and it asks for the password. So it's ChEMBL VM, and then it gets connected to the ChEMBL VM. So that's quite easy. And now connecting to the Postgres, you just pSQL and ChEMBL 18 because they have dumped the ChEMBL 18 data, and then I get connected to the ChEMBL 18 Postgres data. So see the tables, you just /d and you just get to know what are the different tables here. You can see one important thing, since I'll be doing some queries. So uh, there's a RDKit example tutorial for ChEMBL in there, this Cartridge page, where you can get to know how to start with developing this database. So first you need to load the ChEMBL database, and then after that, if you are using ChEMBL, or if you use any other database, so they actually showed with another one here, eMolecules. So so first, after everything is ready installed, so you need to create an extension RDKit and create a schema for schema also, and then after that inside the table here, so you are selecting the mol reg number, mol from C tab, from compound structure. So this is they're selecting these two. This is the function they are using, the mol from CTAB. So the mol files in the compound structures are stored as CTAB files. We call it CTAB. And while passing that mol file as a string, so it converts this mol files into smiles. So I'm connecting, and it will be stored as M here, and then it will generate the it will just select the mol reg and the smiles and will dump into rdk.mols. Then you create the index, which helps you to perform the searching very fast using the gist index. So don't use any other. So gist index it's very fast, and there is also, you need to add the primary key also. Here in the ChEMBL VM, they actually provided this. If you see the mols RDKit, this table, and the FPS RDKit. So the mols table contains. So let me show you mol tables. Mol table contains the mol reg number. So I've run this query, and they have like dumped the data in mols RDKit. So you can perform the substructure search on this table. So again, when you see there is another table named FPS RDKit. So FPS RDKit is the table which is in which you have already generated the fingerprints. So they have generated the mol reg number. Along with the mol reg number, they generated other features like torsion, MFP2. These are the different fingerprints. And the fingerprint section, you can go to this section here, which are the different fingerprints available in the RDKit. Postgres cartridge, they have this Morgan, the Morgan FP, the Feet Morgan, the RDKit and atom pair. So you got to know which fingerprints works like what. So I would highly recommend to you, if you want to know about these fingerprints, I would highly recommend you all to take the chem informatics course, which will help you to understand what are these fingerprints, and what are the so different fingerprints have different functionalities, and they are used for some certain other purposes. So you can also, there's also other functions like there's descriptors where you can generate the log p, the molecular weight, the topological polar surface area, the fraction of sp3 hybridized carbons, and hydrogen bond acceptor, donor, number of atoms, rings, and so on. So these this you will get it here, and also there are lots of examples and different kinds of setting the threshold and everything. So and also they have generated here in this table all the indexes, and also set the small rectangle to primary key. So for example, if I want to run some, let me show you, if I want to run some queries, say for example, if I want to see this one, let's say so suppose I'm performing some similarity searching here, and let me show you. So this, if you set timing, so it will start the timing, it will also show you the time it takes to query the database. So now I just since it is FPS RDKit, so I need to change this. And now it's performing the query. So yeah, and now if you want to see, so there are 66 files. So if I want to limit, you can limit it. So you don't want, you just want the Moldreg number, which are the compounds which are similar. So these are the Moldreg numbers which are similar. So how much is the similarity? Show RDKit. I think it's Tanimoto threshold. It's like set to 0.5. You can set it to something else, like say set it to maybe 0.65 something, and it's set, and then you perform the query. So there are only two compounds which are showing similarity more than 6.65. So here are lots of examples how you can do it, and how you query the database using this. Also, if you like to perform some substructure searching, so let me show you. So say for example this one. So if you want to perform the substructure search, so it's mols RD. Remember the table name. It's mol. So M is the variable name which is given here. So it will select all the compounds from the mol RDKit where so this is the query in Smiles, and it will just find the substructures for you inside the mols RDKit table for all the mol files in the under this given variable. The 377. They're also given some functions like what is this operators if you perform this, and what does these mean, substructure, search operator. It turns whether two molecules are same or not. So yeah, these are the other functions. You can also create this function here. Just copy and paste this function and to get the neighbors around you. As you have seen, so you can set the Tanimoto threshold at different levels, 0.5, 0.6, and based on your query, you can perform the search on this database. Uh, so you can see it will decrease this. So this is 2, and you can set 2.4 and then perform the query. And now it goes on. So it took this amount of seconds, and this is how you can query the database. So I hope you enjoyed this section, and let me know if you have any problems of running the queries and everything. So and also you can contact me via email, or you can contact the ChEMBL team if you find any kind of problems with installing the my ChEMBL on your system, or any errors if you find. I think it should probably be fine with the Mac and with any system. So the virtual you can install on any system, Windows, Mac, or Linux. So yeah, thank you.